Here we're looking at exercise 6b question 14, so one of the application type questions from the rates part of the Algebra 2 chapter. This one's a bit tricky because it's got a few different things you got to keep track of. So before even looking at the particular numbers and so on, I'm just going to look at what's going on. So we have initially two different pipes that are running together into a tank. So, some type of pipe going into a tank. And then we have the fact that they are adjusted. Okay, so they're changed. So from there, we end up with a new kind of pipe system. So maybe that one got a bit narrower, maybe that one got a bit wider, we don't know. But essentially we have two different diagrams going on because there was an adjustment in terms of the rates. So for my notation, I'm going to call this one pipe 1 old. I'm going to call this one pipe 2 old. And then the two together, I will just call pipes together old. Similarly, I'm going to call, so that was that one, that was that one. I'm going to call that one pipe 1 new. This one pipe 2 new. And then together, pipe together new. Alright, so effectively I've got sort of 6 variables that I'm working with, or 6 different things that I'm working with. To keep track of all that, I'm going to draw a table, which will hopefully help me. And in that table, I'm going to have the time it takes each pipe to fill the tank, or each pair of pipes, the volume, and the rate. Now, given that we've got time and we have some sort of volume or capacity for the tanks, we know the rate should be volume on time. Technically, you don't really need to have volume here. You could definitely work this question just looking at time and rate, but I think having volume there just keeps things a lot less likely to go astray. So I like having all 3 elements there to relate to each other. So initially we get told that the 2 different pipes together will fill a tank in 20 on 3 minutes, so there's this bit of information there. So basically we're being told that PT old takes 20 on 3 minutes to fill the tank. Now the volume of the tank we don't actually know, so we can just write down a constant V. That doesn't change, right? It's only the pipes that are changed. And then the rate is just volume on time, so we would end up with V divided by 20 on 3. If you flip the fraction and multiply, we'll end up with 3V on 20. Okay, so that's pretty straightforward, hopefully. Then after the adjustment, we're told that one pipe running alone takes 1 minute less to fill the tank at its new rate. Okay, so let's call that, let's write down pipe 1 old and pipe 1 new. And so pipe 1 old took some sort of time. We can call that, if we like, T1. And the new pipe takes 1 minute less to fill the tank. So T1 minus 1. Okay, volumes are the same as usual. So then the rate is just volume and time. So the rate for the old pipe is V on T1. The rate for the new pipe is V on T1 minus 1. Hopefully that's clear. We're just dividing the volume by the time. The next thing we're told is that the other pipe, so pipe 2, takes 2 more minutes to fill the tank at its new rate. So we're going to write down P2 old and P2 new. So if the old rate was T2, the new rate is T2 plus 2. Volume is the same as usual. So the rate for the old pipe 2 is V on T2. The rate for the new one is V on T2 plus 2. And finally, we're told that the 2 running together, we're told that the 2 running together will fill the tank in 7 minutes, so that's under the new adjustment. So that's PT new is going to be 7. Okay, volume still V, and so the rate is V on 7. Okay, So we've got all that information there, and now we've got to work out what to do with it. The key, as always with rates, is that you can add two rates to get the total of the two. So in other words, it's not true that this plus this, it's not true that this equals that plus that. Okay, we can't just add up the time it takes the two pipes individually and add them up. But we can certainly add, find that this is equal to that plus that. Okay, so we can add up rates to get combined rates. That's the trick, really. So let me get rid of this, just so there's no confusion. Okay, so our first equation that we have is going to be V on T1 plus V on T2 equals 3V on 20. Right, so we have two variables and a third one in V. However, with V, we can actually go ahead and just cancel out the V's. The reason we can do that is because if V equals 0, which would make that a really bad move, the question is kind of trivial. So it's kind of a nonsense question if a tank has no volume. So we can safely divide through by that volume, and because we're not actually interested in volume, okay, we're not asked to find the volume of the tank. So we end up with 1 on T1 plus 1 on T2 equals 3 on 20. And we'll make that our actual equation 1. Okay. So the second one we're going to look at is, that one is equal to that plus that. So equation 2 is going to be, well, for the same reason I can disregard the V as I did in the first one. So I end up with 1 on T1 minus 1 plus 1 on T2 plus 2 equals 1 on 7. Cool. So now I'm actually really happy because I've got two equations and two unknowns, so it's just a matter of solving. To do this by elimination is going to be a bit tough, so I'm going to use substitution. So go down here, use substitution. And so to use substitution, I have to rearrange one of these equations to get the variable on its own. So we'll start with 1. And so if we start with 1, we get 1 on T1 is equal to 3 on 20 minus 1 on T2, which is equal to, if we cross multiply, 3T2 minus 20 on 20T2. So that's 1 on T1. And so therefore T1 is equal to 20T2 on 3T2 minus 20. And then we can sub that into equation 2 over here. However, because in equation 2 we have 1 on T1 minus 1, and that's going to get a bit annoying for us to do inside the fraction, I'm just going to find T1 minus 1 over here before I even sub it in. So T1 minus 1 is equal to 20T2 on 3T2 minus 20 minus 3T2 minus 20 on 3T2 minus 20. This is just because this thing here is equal to 1. Right, so that whole thing there is equal to 1. So if we simplify that, we end up with 17T2 minus 20 on, no we don't, minus and minus should make a plus, so be careful with that, on 3T2 minus 20. Cool, and now we take this entire thing and we sub it into here. Okay, so let me move over here. Just split the page a bit. Okay, so we end up with 1 on 17T2 plus 20 on 3T2 minus 20 plus 1 on T2 plus 2 equals 1 on 7. Obviously we flip this thing, so we end up with 3T2 minus 20 on 17T2 plus 20 plus 1 on t2 plus 2 equals 1 on 7. Okay, so at this stage, usually the best tactic is just to eliminate each denominator. So we're going to do that step by step just to make sure we don't make any silly mistakes. So initially I'm going to multiply everything by 17t2 plus 20. Alright, so this left-hand term will eliminate the denominator, and so we end up with plus 17t2 plus 20 on t2 plus 2 equals 17t2 plus 20 on 7. Then we go ahead and multiply everything by that term. So actually I don't need to write it out here. So we end up with 3t2 minus 20 times t2 plus 2 plus 17t2 plus 20 equals t2 plus 2, 17t2 plus 20 on 7. And so finally, if I keep going down, we end up with, so just multiplying everything by this 7, we end up with 7, 3t2 minus 20, t2 plus 2 plus 7, 17t2 plus 20 equals t2 plus 2, 17t2 plus 20. Okay, so big ugly thing, but nothing very difficult there. It's just a matter of being really careful. And now it's just a matter of expanding. I would suggest at this point pausing the video and doing that yourself, if you like. Okay, so if we go ahead and expand that, we should get, I believe, 21t2 minus 98t2 plus, nope, still minus, minus 280 plus 119 t2 plus 140 equals, and then this side 17 t2 plus 54 t2 plus 40. Now I've actually made a mistake here, see if you can spot it. Alright, so the mistake was that I'd left off the squared from here and here. Okay, so now we get everything to the left hand side. So we can start with these ones here. So 4t2 squared, then we go to these ones here. We end up with minus 33t2, and then we look at these ones here. So we end up with minus 180 equals 0. Now, note that this question, whilst it is quite long and you do need to be careful, you do not need a calculator. So whilst you might not want to do this, so you might not want to do minus 98 plus 119 plus 54 entirely in your head, you should at least be able to do it on paper. So we get this equation here, which initially kind of looks pretty gross, but if you fiddle around with it, I think you can get it out. So I think we end up with 4t plus 15, t minus 12 equals 0. So you can check that yourself and convince yourself that works. And so therefore t2, and so therefore t2 is equal to negative 15 on 4 and 12. Well, for obvious reasons, we can't get negative time, so this is not feasible. Okay, and so we know that t2 equals 12. Okay, so we've got our answer of t2 equals 12, and we know from before that we had t1 equal to this thing over here. Okay, this green highlighted bit. So let's use a different color for that. Okay, so we get T1 is equal to 20 times 12, which is what we found for T2, all on 3 times 12 minus 20, which gives us 240 on 16, which gives us 15. All right, so we've got T2 equals 12, T1 equals 15, and we'd be very tempted to stop there, but if we scroll back to the question and see what it's asking, it's actually asking us to find what time the tank will be filled by each pipe running alone at the new rate. So this is here really the key bit of information. So we found the old rate. Have we just spent a whole lot of time wasted? Well, no. All we need to do to find the new rate is look at these two things here. Right, so the new rate for P1 is T1 minus 1. The new rate for P2 is T2 plus 2. Okay, so pipe 1 will take, well, 15 minus 1 is 14 minutes at the new rate. And pipe 2, if we add 2 to 12, we also get 14 minutes. And that's it.